Most people don't understand how a microswitch works, so it becomes one of the first items changed in a machine. If the problem isn't the switch, the repair person wastes a lot of time and money and increases the customer's downtime. Because this is something I'm asked about a lot, I created this video to better explain how this switch works. Simply put, a microswitch changes the direction of power when the arm is moved. Although we call it a microswitch, it's better known as a snap action switch because it uses a spring to open and close connections inside of it. If you move the lever on a good switch, you can hear the spring snap back and forth. This gives it the ability to change the direction of power quickly between two devices, like these red and green lights. In order for this to happen, the switch uses 3 connection points, and they're labeled as C for common, NO for normally open, and NC for normally closed. A microswitch works by using a spring-loaded lever to open and close a set of internal contacts. Power is typically attached to the common terminal. This leads into the switch and energizes the spring, and because the spring is touching the normally closed pin, sends power out here. This is called the resting state, meaning there's nothing pushing against the activating arm. The moment the arm is moved, the spring snaps into a new position and changes the path of power by sending it out the normally open pin. Now that you know how the switch works, see if this helps you understand how it's drawn in a diagram. I'll draw the same circuit that uses the red and green lights. We'll assume we're working with 120 volts, so we should have 3 wires, line 1 bringing the power in, neutral taking it back out, and a ground. And I bring the power into our microswitch. The circles indicate wire connections. Our switch has 3 and our diagram has 3, and I label them just like on the switch: common, normally open, and normally closed. Now we can add 2 additional wires, one from normally open and one from normally closed, and connect each to a light. Lastly, both lights are connected to a neutral. Now let's walk through the circuit. In this case, power enters into the common terminal and exits out the normally closed terminal because we draw components in the resting state. The power continues through the wire and passes through the red light and out through the neutral. Power passing through causes the red light to be on. The microswitch's arm is not drawn in the diagram, but once something moves it, the internal spring changes to the normally open terminal, allowing power to travel to the green light and at the same time interrupting power to the red light. Because there are only 3 terminals, the switch is very easy to test. After locking out the circuit and removing the wires to the switch, set your multimeter to test for continuity. With the switch in its resting state, place your test leads to the common and normally closed terminals and see if your meter tones. If it does, move the switch's arm to its non-resting state and test from common to normally open. If your meter tones during both tests, the switch is good. One mistake many people make is taking the switch out of its mounting in order to test. Moving the lever by hand sometimes causes false readings, so always test the switch when it's mounted and use the machine's controls to change states. So there you have it, everything you wanted to know about a microswitch, and maybe a little more. Remember, even small amounts of electricity can be dangerous, so don't work on any electrical devices unless you're certain the power's off and that you're comfortable working on it. I hope this helps. Thanks for watching.